Okay, all right. So I have shared my screen and I suppose everyone is able to see the screen. Okay. All right. So let's talk about the first question from the first chapter, that is quadratics. Okay. The question says a curve has equation y equals 1 by x plus c, and a line has equation y equals cx minus 3, where c is a constant. Find the set of values of c for which the curve and the line meet. Okay. So first of all, this time around, you need to notice one thing, that the equation of curve is not quadratic, right? But it's completely fine. This is not a quadratic equation, but it is fine. You will see at the end, once we use both the equations together, you would get a quadratic expression. Okay. So this is your curve. This is your line. And what is the condition? The condition is find the set of values of c for which the curve and the line meet. Now we know that we have two scenarios where the curve and the line meet. Number one, when the line is intersecting the curve at 2 points. And the second one was when the line was intersecting the curve at 1 point only. So both of them are basically the cases where the curve and the line meet. Okay. So we need to use both of them. This means b square minus 4ac greater than 0 would be used, because obviously the line would be cutting the curve at 2 points. Okay. And then b squared minus 4ac equals 0. This would also be used because the line and the curve would be meeting at 1 point here. Okay. They did not mention the number of points of intersection. They just said the line and the curve should meet. So we need to combine these two conditions. When we will combine these two conditions, this is going to be the condition that we will be following. Discriminant would be greater than or equal to 0. Okay. So we have combined this condition and this condition in order to get this one. So this is a direct question. In the question, we have been told we have a curve, we have a line, and they are meeting. That is it. You don't know if they're meeting twice or if they're meeting once. So we have combined both the scenarios. This was for 2 points and this is for 1 point, right? But we have just combined them. Okay. So first of all, we need to make the quadratic equation. Now, how do we make the quadratic equation? It's simple. It's y equals something. It's y equals something. I need to equate both the equations, right? So this would give me 1 by x plus c. This is my curve and it is equal to the line, that is cx minus 3, because both are equal to y. So I can directly just equate them. Now I need to simplify it in order to get my quadratic equation. So for that, I can take LCM on the left side and it would give me 1. The LCM is going to be x. So it would give me 1 plus cx. I hope you guys are okay with this. If not, you need to tell me right now. Okay. And then this is equal to cx minus 3. Next, I will take this x to the right side and it would give me 1 plus cx equals x into cx would give me cx squared minus 3x. Okay. And now I'm going to simplify this. So I can take everything to the right side. So it would give me 0 equals cx squared minus 3x minus cx minus 1. All right. And then this is cx squared minus x into 3 plus c. I need a, b and c separately. So I'm just, making them, I'm just taking x common here. And then we have minus. Yes, I'm sorry about it. Okay, I've shared my screen again. Right, Munya, can you please tell me if my screen is visible or not?
Yeah, it's visible now.
Okay, all right, okay. Okay. So basically, we we're doing this question and we are basically at this point. This is the quadratic equation. Now I need to find a. This is a. The coefficient of x squared is a. Then this is my b and this is my c. Okay, so I need to plug in the values of a, b, and c in the conditional inequality I made. So a is going to be c, b is going to be minus 3 plus c, and c is going to be minus 1. Then I know this was the inequality for this condition, so I will just plug in the values here. It was b squared minus 4ac greater than equal to 0. B squared is minus 3 plus c squared, then minus 4 into a is c, and then c is minus 1. Okay, and then this is greater than equal to 0. I am going to simplify it. This can be written as 3 plus c squared, because square of negative number is same as the square of positive version of that number, and then plus 4c greater than equal to 0. I'm going to open this, expand it, and finally I would get c squared plus 10c plus 9 greater than equal to 0. Next, I'm just going to factorize it. So the two factors would be c plus 1 and c plus 9 greater than equal to 0. Now, it is a quadratic inequality. So I'm not going to make conclusions directly. I need to make the graph. So it is positive. The coefficient of c squared is positive. So it would be a U-shaped graph. And the critical points would be minus 1 and minus 9. So the x-intercept is minus 9 and minus 1. And this is going to be the rough quadratic curve. And this thing is greater than 0 means that we will be focusing on positive y-axis. So we have these points and these points. So this would imply that c is less than or equal to minus 9, or this would imply c is greater than or equal to minus 1. So this is going to be the answer. Okay, so I'll just go through it once again, and then if you have any queries you can ask me. Again, this was a typical question we have been discussing already. We had a curve that was not quadratic. This was the only difference, right? Then we had a line, and we were told that you need to find the set of values of c for which the curve and the line meet. Now we know that we have two scenarios where the curve and the line meet. Number one, when the line is cutting the curve at 2 points, there the discriminant is greater than 0. Number two, when the line is cutting the curve at 1 point only, we also call it that the line is tangent to the curve for that. Okay, so we had to combine both the scenarios, and this was our inequality, okay, corresponding to this condition. This is what we would use. Okay, now I had to make my quadratic equation first, so I equated the curve and the line. I simplified, and this is what I got. Then I had to extract a, b, and c. I got a, b, and c. This was the conditional inequality. I plugged in b, then a, and then c, and I've simplified it. It was obviously a quadratic inequality, and these were the two factors. I made the graph in order to find the final answers, and I got c is less than equal to minus 9, because these are the points, and I can see that we are going to towards the left side, and here we are going towards the right side. So that is why this would be the answer. Yes, now if anyone has questions, please ask me.
No, ma'am.
Okay.
Miss, can you show the variant of the picture?
Okay, sure, definitely. One second. Okay, I'll just check that from my phone. 1 second. All right, it is the 2018 exam and paper 1-2. Okay. right?
Miss winter or summer?
It is basically the February-March variant. I'll just send you a screenshot. Like usually it's May, June, and October, November, but in some countries the exams are basically in February and March as well. So it's that variant. I'll just send the picture on WhatsApp in the group. Okay.
Okay, miss.
Yeah, but the paper code is same, so we need to practice all the variants. All right, I've shared it, so you can just see the paper, exact paper code over there. All right, and any other questions, Motasam? Are you okay with this?
Yes.
All right, okay. So I hope that we are good with the first part of the question. Let's talk about the second one, okay? All right, now the second part says, the line is a tangent to the curve for two particular values of C. For each of these values, find the x coordinate of the point at which the line touches the curve. All right, so we need to understand the scenario first and then we will solve the question, okay? Again, this part is coming from the previous part. So the line is tangent to the curve for two particular values of C, okay? For each of these values, find the x coordinate of the point at which the tangent touches the curve. Okay, forget about the second part. Let's talk about this part first. Let's talk about those two particular values of C. Okay, now you don't need to do the entire working again. Let's just scroll up and see. We know that this time around for the second part, the scenario has changed, but everything is same, right? In the previous part, the statement was the curve and the line meet. So this is what we used. Now the examiner is saying the curve and the line are meeting at one point only, or in other words, the line is tangent to the curve, right? So for the second part, the condition would be changed that the discriminant would be equal to 0, but everything would be same, like our A, B, C are going to be same. So everything would be same till this step, okay? Everything would be same except this sign. This would be equal to sign now. So you are not supposed to do the entire working. You can directly start off from here. C plus 1 and C plus 9 was greater than equal to 0 for the previous part because of the condition. Now we would be having discriminant equals to 0, and after plugging in the values in the discriminant, this is what we would get. So this is equal to 0. And the two particular values of C are going to be C equals -1 and C equals -9. Again, I'll repeat. The line is tangent to the curve at two particular points. Only the condition has changed. So only the sign would change from this to equal to sign. Every other thing is same. Okay, now we have the equal to sign, and when we have the equal to sign, it would be C equals -1 and C equals -9. Okay, this is what we are going to have. Now let's talk about the main or the next part of the question. For each of these values, find the x coordinate of the point at which the tangent touches the curve. Okay, now this is basically the value of C. The examiner wants you to find out, for each of these values, find the x coordinate of the point at which the tangent touches the curve. All right, okay, so this was the line and this was the curve. Okay, I combined them and this was my final equation. I'll write it again. I'll write it here. Cx squared minus x into 3 plus c minus 1 equals 0. This was the final quadratic equation. Now the examiner is saying, for these values of c, -1 and -9. For these two values of c, find the value of x basically, right? So it's very simple. I'm just supposed to plug in the value of c here, and I would get an equation with x only, and I know how to solve a simple quadratic equation, okay? So I will be writing this equation again over here. Cx squared minus x into 3 plus c, and then it was -1 equals 0. Let me go up and see if we have written the equation correctly. Yes. I need to plug in c equals -1, so it would give me minus x squared minus x, 3 minus 1, -1 equals 0. So minus x squared minus 2x minus 1 equals 0, and I'm going to take minus out from here, or I can take minus common. So it would give me x squared plus 2x plus 1 equals 0, and then I can just divide this minus on the other side, and finally the equation would be x squared plus 2x plus 1 equals 0. Okay, the question was about finding the value of the x coordinate. So I will just find the value of x coordinate. So it would be x squared plus x plus 1 equals 0. I can take x common, x plus 1 plus 1 common, x plus 1 equals 0. And this is going to give me x equals -1. Okay. So for c equals -1, x is equal to -1 as well. Now can all of you find the value of the x coordinate for this c? The equation is again this one, but this time around you're supposed to plug in -9 in c, okay? And you would again get a value for x. Please do that. C is equal to -9, and the equation would become -9x squared minus x into 3 minus 9 minus 1 equals 0. -9x squared plus 6x minus 1 equals 0. Please simplify this and find the value of x, okay?
One-third.
Very well done. Excellent. Very good. And what about the other students, Mutasam, Ahmed, and Rafe?
1 minute, ma'am.
Okay, sure, sure. Take your time, all of you, and find the value of x, okay? Very good. Well done. Okay, all right. Let's do it together. Now I got two answers so far. So this is the quadratic equation that we need to simplify. I need two numbers such that when I multiply them, I get positive 9x squared, and when I add them, I get 6x. So it would be minus 9x squared plus 3x plus 3x minus 1 equals 0. I can take minus 3x common, and it would give me 3x plus 1, and then one second, minus 1, sorry. 3x minus 1, and then again I can take plus 1 common, and it would give me 3x minus 1 equals 0. And it is minus 3x plus 1, and then it is 3x minus 1 equals 0. So we are going to get x equals, for both of them, right? For both of them, it is going to be x equals 1 by 3 for this one and for this one, for both of them, right? So when we use c equals minus 1, I got x equals minus 1. And when we use c equals minus 9, I got x equals 1 by 3. The thing that we need to understand here is that the question was very simple, but the statement seemed to be a bit complicated, okay? The statement was basically, the line is a tangent to the curve for two particular values of c. Now, this is the condition. So this would mean that the discriminant is equal to 0. You are not supposed to find the discriminant again. We already had the discriminant. This was the discriminant. We simplified, and this is what we got. So the examiner would be completely fine if you're using that thing again. Okay. Now it would be equal to 0. This would mean c is minus 1, c is minus 2. So these minus 9. So these were the two particular values of c. Okay. Once you have the two particular values of c, you were supposed to find the value of x. So then we had to use this quadratic equation, which we got by combining both the equations, right? Why? Why didn't you plug in the value of c here directly? Because this equation would not give you the x coordinate. You have y and x and c. You have three unknowns here. If you will plug in one unknown value, if you will have two unknowns, for example, if this was the equation, and you know that c is equal to minus 1. So this would become minus 1. Now this equation cannot give you the value of x because y is there as well. Okay, so you need to use the equation which we got after combining these two equations, right? So this was the equation that we need to use. So we have plugged in c equals minus 1 here, and you got x equals minus 1. And then we plugged in c equals minus 9, and we got x equals 1 by 3. So this was the second part of this question. Yes, any confusions with this one?
No, miss.
All right, okay. What about you, Motasam? Is it okay? Motasam, did you understand this? Yes, Motasam, can you hear me? All right, okay. So this was the first question. Let's talk about another question. Okay. Now it's interesting. Let's see. The second question is basically this, that and obviously this question is from other exam. It says the equation of a curve is y equals x squared minus 6x plus k, where k is a constant. Find the set of values of k for which the whole curve lies above the x-axis. Okay. This is your equation. You need to find the set of values of k for which the whole curve lies above the x-axis. Okay. So I'm just making a rough sketch. Okay. A rough sketch. I'm not sure about the curve at all. For example, this is the curve. Okay. The only thing I know is that the coefficient of x squared is positive. So it is going to be something of this type. So you need to find the set of values of k for which the whole curve lies above the x-axis. Above the x-axis basically means for on the positive y-axis, and that would mean that y is greater than 0, right? It is y equals x squared minus 6x plus k. Since the examiner is saying you need to find the set of values of k for which the whole curve lies above the x-axis. So above the x-axis means they're talking about the positive y-axis, and there it would be greater than 0. Y would be greater than 0, right? We know that y is greater than 0 here. So this is basically the situation. This is the situation, okay? This is the inequality we need to focus on. All right, so I can just focus on the right side. It's x squared minus 6x plus k greater than 0. Okay, find the set of values of k for which the whole curve lies above the x-axis means that I need to find such values of k for which this expression is always positive. Now, I am not sure about it like this, okay? I'm not sure about it at all because I can see a minus 6x there. Now, I don't know what value of k would basically help me with having, all this expression greater than 0 or positive. So for this, again, we need to do something similar that we did yesterday. We will be applying the completing square method, and you will see why are we doing that, okay? So this would give me x squared minus 6x. Step 1 is already done. The coefficient of x squared is 1, so we are not supposed to take anything common. That's clear. Then step 2 is we need to look at the coefficient of x, that is 6. You need to add and subtract the square of half of this number, that is 3 and 3. And then plus k was there already, okay? So finally, this is going to give me x squared minus 6x plus 3 squared minus 9 plus k greater than 0. Now I can write it as x minus 3 whole squared and then k plus k minus 9 greater than 0. Now I am very clear about it. After applying the completing square method, this is an equivalent version of this, okay? So it means that this is obviously square of something, so it is going to be positive, right? So this is positive, and now I want k minus 9 to be positive. So I can directly write it down this way. K minus 9 should be positive, and this would mean that k is greater than 9. So this is going to be the answer. I'll repeat. This was a different question. Like here, they did not talk about the line and curve and about their meeting points and stuff like that. No, they just said that the whole curve lies above the x-axis. Above the x-axis means that they are talking about the positive y-axis. And when they're talking about the positive y-axis, this y would be greater than 0. Since this y is equal to this, so this would also be greater than 0. Simple. When this is greater than 0, at this point, I'm not sure about the values of k for which this entire expression would be positive. I had to apply the completing square method and I got this. Now I know this is square of something. Square of something is always supposed to be positive. So this would be positive. I want k minus 9 to be positive because only then this entire thing would be positive. If I want k minus 9 to be positive, I've made a separate inequality for it, and this is basically giving me k is greater than 9. So this is going to be the answer for this one. Now please tell me if you were able to understand this question or not, and be very, very honest here.
Miss about the thing, x minus 3 whole square. Miss, what's the point of it? Like, why do we need to ensure that it is positive or not?
Okay, I'll tell you. That's a very good question. Basically, we need to find the values of k for which this entire expression is positive, right? Now, at this point, I was not sure. I could not see, I could not find any set of values of k directly. I applied the completing square method, and after that, this is what I got. Now, I have x minus 3 squared plus k minus 9. Okay, I want this entire thing to be positive. I know that this part is already positive because it is square of a number, right? It is positive. In order to have this entire encircled thing positive, I can see that only this has to be positive. This is going to be positive always. So this was basically the reason why we had to apply the completing square method, because now x was basically inside this square, and I could see that this is always going to be positive because it's square. Even if I have a negative number inside this square, it would give me positive, right? In order to
Yeah.
have this entire thing positive, this was supposed to be positive and this was supposed to be positive. This is already positive. In order to have k minus 9 positive, I need uh, the values of k to be greater than 9. Okay, so this was the question. We had to find the set of values of k for which this entire expression was greater than 0. So this is always greater than 0. In order to have this entire thing greater than 0, I wanted to find out that for what values of k would this expression be greater than 0, and that is basically k greater than 9, right?
Yes, miss. Got it.
Are you sure?
Is it so because the y is greater than 0, so we will need this entire thing in the circle to be greater than 0.
Yes.
It's like even if we have one negative value, for example, let's just suppose that it is negative. So if this is going to be greater than this, then
Exactly.
at the end of the day, we'll be getting greater than 0, right?
That is right. That is right. That is very right. But we need to be very sure about. I get your point. You're saying that if x minus 3 is something positive and it's more than k minus 9, so automatically that would be greater than 0. I get your point. Okay, but we are not sure about it. We just want a safe set of values of k for which this set is always positive, right? That is why we are doing it this way.
Okay, miss. Got it.
Yes, but your concern was valid. I get your point. That is right, actually.
Okay.
All right. And what about the other students?
Miss, I just have confusion in the beginning. Miss, how did you know that it is greater than 0?
Okay, I'll tell you. Because this time around the statement was the whole curve lies above the x-axis. So above the x-axis means this is the x-axis, this is the y-axis. So basically they're talking about this, right? They're talking about the positive y-axis. If something is above the x-axis, so they are basically talking about the positive y-axis. When they're talking about the positive y-axis, it means y is going to be positive. So that is why, since y is equal to this thing and y it would be greater than 0 because y is positive, that is why this would be greater than 0.
Okay, thank you, Miss.
Okay, all right, welcome. And what about Ahmed and Munja?
Oh, thank you, ma'am. I'm okay.
Or Ahmed, are you okay as well?
Yes.
Okay, all right, great. Okay, okay. So let's talk about one last part of this question. Find the value of k for which the line is a tangent to the curve. Okay, I think you guys can try doing it right now. I'm just going to, yeah, everything is clear. Let me just clear this part as well. Okay. All right, so now this is the curve. Y equals x squared minus 6x plus k. Y equals x squared minus 6x plus k. This is the curve. The question is find the value of k for which the line is a tangent to the curve. Okay. So we have line, we have curve, and now the condition is tangent. So tangent means that the discriminant would be equal to 0. Very good. Please just combine both the equations, find your quadratic equation, then take out ABC, plug in ABC, and tell me the value of k. I'll wait for 3 minutes. Please take your time and do it, okay? I would not mind a wrong answer, obviously. Just try doing it. Very good, Ahmed. Well done. Your answer is correct. And what about the other students? Please try doing it. Yes, Munya, very good. That is also correct. Okay. So let's try doing it together quickly. So this is the curve. This is the line. Let me write it down this way. Y equals minus 2x plus 7. It has to be like this. Only then we would be in the position to equate them. Okay. So now I need to equate both the equations. So it would give me x squared minus 6x plus k equals minus 2x plus 7. I will just simplify this. It would give me x squared minus 6x plus 2x plus k minus 7 equals 0. And finally, I am going to get the values of A, B, and C. All right, so the coefficient of x squared is A, this is B, and this entire thing is C. Discriminant is supposed to be equal to 0 because this time around the condition is tangent. It is minus 4 squared minus 4 into 1 into k minus 7 equal to 0. And it would give me 16 minus 4k plus 28 equals 0. And finally, we are going to get minus 4k yes, it would be minus 4k. And then we have 16 plus 28. So that would give you 44 equals 0. So k is going to be minus 44 divided by minus 4. And it would give you 11. So k is equal to 11. This is going to be the answer. Okay, it's positive 11. So again, this question was easy. This was a straightforward question. A line, a curve, tangent. Tangent means discriminant would be equal to 0. That is okay. We had to find the quadratic equation. This was the quadratic equation. This was A, B, C. I plugged in A, B, C. I got this. And after simplification, K was equal to 11. Again, as I've told you earlier as well, the examiner would tell you if you would be getting 2 values or 1 value, right? If it says value of K, then just know you would just get 1 value of k. Okay, so this is going to be a good hint for you. All right, any difficulties in this question? Anyone who has some problem?
No, miss.
Okay, Modusam, are you okay with this?
Yes, miss.
All right, okay, great. So I'll stop sharing this. I'll stop